Ever wonder what people actually mean when they say neural network? It sounds like science fiction, but honestly, it's way simpler than the name makes it sound. Let me show you. Okay, picture this. You walk into a bakery and smell something amazing. Your nose picks up the scent. That signal travels to your brain. Then little groups of brain cells light up, one after another, until your brain finally says, "Oh, that's fresh bread." A bunch of tiny units, passing signals along, working together to reach an answer. That, in a nutshell, is what a neural network does. It's a bunch of simple little units, arranged in layers, passing signals forward from one layer to the next until the last layer spits out an answer. Now here's the thing. People love to say neural networks work like the brain. That's loosely true, but I want to be honest with you. It's inspired by the brain the way an airplane is inspired by a bird. A plane has wings, sure, but it's not a bird. It doesn't have feathers, it doesn't eat worms, it doesn't lay eggs. Same deal here. A neural network borrows one tiny idea from biology, little units passing signals, and runs with it using math. That's it. No consciousness, no thoughts, no tiny brain in a box. So let's open up the box. Imagine 3 rows of dots. The first row on the left is the input. Say you're showing the network a photo. Each dot in that first row holds a number, maybe how bright a pixel is. Then those dots are connected by lines to the next row of dots, and those connect to another row. And finally, the last row gives you an answer, like cat or dog. Each dot is a little unit. Super simple. It just takes in numbers, adds them up, and passes a new number forward. No big deal. Now here's the magic part. Every line between the dots, every connection, has a strength. Think of it like a volume knob. Some connections are turned way up. Some are turned almost all the way down. When the network is learning, it's literally just adjusting those knobs. Up a little here, down a little there. Over and over, millions of times, until the answers start coming out right. That's really all training is. Tweaking knobs. Let me put it another way. Imagine a giant office building. On the first floor, workers look at raw stuff coming in. Pixels, words, sounds. They each shout a quick summary up to the second floor. The second floor workers listen, but they trust some coworkers more than others. That trust level, that's the connection strength. They mix what they hear and shout their own summary up to the third floor. And so on. By the time you reach the top floor, the building has turned 1,000,000 pixels into, yep, that's a golden retriever. Which brings me to the last piece. Depth. You'll hear the phrase, deep learning, everywhere. Deep just means lots of layers. Lots of floors in the building. Why does depth matter? Because each layer learns something a little more abstract than the one before it. With an image, the first layer might just notice edges and bright spots. The next layer combines those into shapes, like circles and curves. The layer above that puts shapes together into eyes and ears. And the top layer goes. Those features add up to a face. A shallow network can only learn simple patterns. A deep one, with many layers stacked up, can learn really rich, complicated stuff. Language, faces, voices, whole conversations. Same basic idea, just way more floors in the building. So that's a neural network. Layers of simple units. Connections with adjustable strengths. Loosely inspired by the brain, but really just clever math. And depth is what lets it tackle the hard stuff. Tomorrow we'll talk about training versus inference. Basically, the difference between the network's study time and its exam time, and why one is so much more expensive than the other. See you tomorrow on AI in 5.